Hello everyone, welcome to the next lecture on the PY question series. Today I will explain you how you can solve the problems related to the entire function. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the CSIR UGC net and you can see the various lecture related to the PY question of the countability, eigenvalues, rank, matrix, determinant, numerical methods, Volta equations and many more available in this playlist. You can subscribe my YouTube channel so that when I upload my next video, you can get the notification. In this lecture, we will see how you can solve the functions or problems related to the entire function. Entire function is also be abbreviated as the analytic function or the holomorphic function. Now, in this lecture, we will cover about the 40 plus questions related to this topic and it cover the part B and part C both. Now, before I directly move on to the PY question series, let me quickly recall you the some concepts as well as the tips where you can solve so that by using of these shortcut tricks, you can solve each question in the 10 to 15 second time. The first and the most important concept which is used in the entire function is Cauchy-Riemann equation. Whenever you have the function of the complex variable f of z, where u and v are my functions of the x and y. This in the Cartesian form. If you have written the polar form, then f is my r e raised power iota theta. Then this function f will satisfy the CR equation if it satisfies the following property. That means the partial derivative of u with respect to x is equal to the partial derivative of v with respect to y, and partial derivative of u with respect to y is minus partial derivative of v with respect to x. Both the equation must be satisfied, then you can say the CR equation hold. On the other hand, if you have the polar coordinate, then you have to firstly find the u. U is my real component of the f, v is my imaginary component of the f. So once you have the polar coordinates, then you can equate the coefficient of the real and complex. Then partial derivative of u with respect to r is 1 over r partial derivative of v with respect to theta. Similarly for this case. Once this condition is satisfied, then you can say the CR equation hold. Make sure if the CR equation of the any complex function satisfied, it doesn't mean that they are analytic function. In order to prove that the analytic function, you have to satisfy two conditions. The first one is f must satisfy these properties. Second is the partial derivatives are my continuous. Or instead of that, if you prove that the partial derivative of f with respect to z bar is my 0, then it is analytic. For example, if I say z, what is the partial derivative with respect to z bar is 0. That means this is my analytic function. E raised power z, again the partial derivative with respect to z bar is 0. So e raised power z is also analytic function. Another most important result that we use frequently in the complex analysis is Leibniz theorem and the identity theorem. This result will related to that when the function is a constant. That means if you have a function f which is my entire or called as the analytic, plus if you prove that the function is my bounded, then that function is my constant. Or you can say a non-constant entire function is my unbounded. What are the various conditions when you can say the function is a constant? The first point is definitely f is my bounded, fine by the definition. Second point is instead of the f, if you prove either u or v is bounded. If you prove either u or v is bounded, then again the function is bounded. If you prove the function is bounded, then again the function is constant. If you prove that for the real alpha and beta are my scalars and alpha of u plus beta of v is my less than equal to k or greater than equal to k, all implies the function is my constant. Make sure either of one plus f is my entire, then you can say function is constant. What is the identity theorem? If you prove that the function is your analytic in the domain D, if you find all those zeros, the set of all those zeros, like if I define the set of all those zeros, what is the meaning of the zero? F of z is my 0. And if you find the limit point of this function, if the limit point belongs to my this domain, then you can say the function is identically 0. Similarly, if you have the two function f and g, if you define the set of f minus g and the limit point of the f minus g belongs to the domain, then f and g both are my identically same. Next result is there is a non-constant entire function. Remember, this result is for the constant entire function, and this function is non-constant entire function. What is the example of the non-constant? E raised to power z, 1 plus z. These are the non-constant entire function, sine of z, and so on. Every non-constant entire function omits at the most one complex number. What does it mean? If you define as a complex function from C to C, every non-constant entire function, that means image of the f is, what is the meaning of that? At most one, either the C or C minus at most 1. Fine. Or you can say if the entire function omits the two values, then the function is my constant. Or in other words, if you have the 2 points A and B such that it does not belong to the f of C and A and B are not equal, then you can say the function is constant. For example, if I say f is any non-constant entire function such that f of z is greater than 10, what does it mean? That means it satisfies this shaded portion, but simultaneously it omits all those points which satisfied less than equal to 10, less than of 10. That means by this Picard's theorem, it's my constant. Or you can say if the function has a singularity at the most pole, then the function is necessarily a polynomial. Another important result is if you have the entire function f such that f of z divided by z or z raised to power n, then you can say the function is my constant in the first case. In this case, function is my polynomial of degree less than equal to n minus 1. Clearly say in this case, what is my n? N is my 1. If you compare, then 1 minus 1 is 0. That's a constant function. And that point I already told you, if you have the entire function, it admits at the most 1 point, then its image is my either C or C minus A. You can see also my previous PY question series related to the Schwarz-Lemma identity theorem, complex integrations, that is the residue theorems, Mobius transformation power series, all are available at my YouTube channel. That's why I'm asking you, you can subscribe, you can like my videos and comment on this. I also explain the residue part separately for the GATE as well as the CSIR exam. If you are new to my YouTube video, you can scan and join my WhatsApp group. Now let's start with the PY question series. What is given to you? F is a function which is defined as u plus iota v, such that v is my 3xy square. Then f can't be the entire function, f is the entire function, f is the entire function, f is not differentiable. First of all, v is my polynomial. Fine. Every polynomial is my differentiable. So v is not differentiable is the cancel. Now, how you can check about the entire function? Remember, if you have the function of the u plus iota v, it's said to be the entire when u or v are my harmonic function. Fine. If the u or v is not harmonic, then it is not entire. Now, since v is my given to u, so my target, what is my target? To check whether vxx plus vyy is 0 or not. So let me check quickly. What is the v of x? 3y square. Vxx 0. Vy 6xy. Vyy 6x. Clearly say the sum of them is my non-zero. That means it is my not harmonic. It is not harmonic. It implies not entire. So once it is not entire, so second and the third option cancel. Right option is A is my correct answer. Another one is f is my u plus iota v and u is given as 3xy square. Then f can't be harmonic, holomorphic, u is not differentiable. Again, u is my polynomial, so polynomial is my differentiable. Again, I need to find harmonic function of the u. So 3y square. Uxx will be my 0. Uy 6xy. Uyy 6x. Clearly say the sum is my non-zero. That means u is not harmonic. If u is not harmonic, it means f is not entire. That means f is not holomorphic function. I hope you can like and comment on my this video. Let p of z is a function of the polynomials where ai's are my complex numbers, and let ku of z is my this. Firstly, you can take any of the polynomials. So let's say n is my 1. Then your p of z will be z plus a naught, where a naught is my complex number. Let q is my, when n is 1, it is my 1 plus a naught of z. Now, given that p of z is less than equal to 1 for all z, mod of pz. Now I can substitute the value of this. Z plus a naught is my less than 1. Fine. Now, but we all know this value, I can return this number as of this nature. Fine. Now it is given that z is my less than equal to 1. That means this number is 1 plus of this number. Now, when this number will be less than equal to 1, this is my p of z. Fine. When it will be less than equal to 1, only if mod of a0 will be 0. Because if a0 is my non-zero, then the absolute value will be the positive, then this number will be my greater than 1. So that means a0 will be my 0. Fine. So once a0 will be 0, what is my q of z? Q of z will be 1 for all z. So q of z is less than equal to 1 because equality appears. Yes, satisfied. Q is my constant function, satisfied. P of z is, when a0 is my 0, what is my p of z? P of z is my only z, and n is my 1. Yes, it's satisfied. P is my constant function, that's a polynomial. It is not a constant function. So right answers are A, B and C are the correct answers. Look at this another one. F is a real valued harmonic function. That means fxx, fyy is my 0. Define the function g and h, which are the following are my entire or the anchor. What is the meaning of that? How you can prove the entire? G is my holomorphic function. If I prove that, G will satisfy my harmonic function. Fine. So firstly find the partial derivative of G with respect to x. It is my fxx minus iota fxy. What is the G of xx? It is my G of x. No, it's a harmonic. Your target is to harmonic. That means entire. You have to firstly satisfy the CR equation. Fine. So that means if G, for the G, firstly I call this is fx plus fx minus iota fy. So u is my fx, v is my minus fy. Now for the CR equation we will see what is the ux. It is my fxx. What is my uy? fyx. What is the v of x? Minus fxy. And what is the v of y? Is my minus fyy. Now what is your target is you check whether ux is equal to vy or not. Fine. Now clearly say f of x is equal to minus of, so that means this property hold. Second is v of x must be minus of uy. So again you can see this property satisfied. Yes, G is my G satisfied CR equation. Now whether these are my continuous? Yes, because it is a harmonic function. So these are my continuous as well. This means G is my entire function. So G need not be holomorphic, cancel. Both are is equal to the 0 function, that's a cancel. Now look at the second for the case of the h. What is the h? What is the u in case of the h? That is fx. V is my fy. What is the ux? Fxx. Uy, fyx. Vx, fxy, and vy is my fyy. Clearly say my target is to prove this number which is not satisfied, because fxx plus fyy is 0. That means fxx is minus fyy. So this property not satisfied. That means h not satisfied the CR equation. That means h is not analytic function. So G is holomorphic. H need not be holomorphic is the correct option. B is my right answer of this problem. Which of the following function are my entire functions and have a simple zeros? F is my simple zero at z is iota k. Remember, if you have the function f of x is 0, fine, then it has 0 at x is equal to alpha. What is the mean? Simple 0. What does it mean is, that means f of alpha is my 0, but f of first derivative is my non-zero. That's the meaning of the simple root. Simple 0 means that's a simple root. So now I can check about these properties. So look at, firstly start from the fourth. What is the f is? E raised to power cz. What is the f of iota k? E c of iota k, where k is my all integers. So I can choose k is my 1. So it will be e raised to power iota c, which is my non-zero for some k. Fine, it is not 0. That means the first property is not satisfied. So this option is cancelled. Look at the third option. If I substitute z is iota k, so z is iota k, that means f is b cos iota is minus k minus 1 over 4. So cos negative is a positive. I can multiply them. It's a 2 pi k plus pi over 2. Cos 90 plus is minus b sine 2 pi k. Now since k is my integer and we all know sine 2 pi k is always 0. This property is satisfied. Now we can find the f dash. What is f dash is minus b sine 2 pi, b iota is outside, iota z minus 1 over 4. Then I can check about whether ik is a 0 or non-zero. So it is minus sine 2 pi, I can take minus common, it is k plus 1 over 4. If I open this bracket, it's a sine pi by 2. Sine pi by 2 is my cos 2 pi k, and we all know cos 2 pi k is always my 1. This number is always 1. This is non-zero. So yes, it has a simple 0. Look at this third option, second option, f of iota k. That means a sine 2 pi iota z. So that means minus 2 pi k. Sine minus will be, sine 2 pi k will be 0 when k is my integer. What is the derivative? 2 pi iota a cos 2 pi iota z. Now clearly say f dash of iota k. This number is my non-zero. Fine, because cos of 2 pi iota is always 1. So this number is my non-zero. Therefore this is also the correct option. First option, n is my greater than equal to 1. I can choose n is my 1. Then your function will be, when n is equal to 1, it is my a1 of z plus a0. Then what is the f of iota k? a1 iota k plus a0. Clearly say which is my non-zero. Therefore this option is also cancelled out. So the right options are my B and C are my right answers of this problem. F is my entire function, Z is given to be this function, U is my real, V is my imaginary. Which of the following satisfy? F is my entire, That means it satisfies the CR equations. That means u of x is Vy, v of x is minus, sorry, u of x is, u of y is minus of Vx. Now uxx, first option, you can partial derivative first function with respect to the x. uyy minus vyx. So clearly say if you add them, it will be 0 because the function is continuously differentiable. So the first part is satisfied. Vxx, so I can differentiate this with respect to the x. Uxy is minus Vxx, and Vyy, Uyx is Vyy. So clearly say if you add them, will it satisfy? If you Vxx plus Vyy, it is not set. Yes, if I take this is negative, this is positive, if you add them, it is a 0. So yes, this also satisfied. Third property, ux, your target is to prove uxy minus uyx, which is 0 or not. So clearly say from does it satisfy? Uxx, where is the uxy? I can differentiate this with respect to x, so you will get this number. Uyx, you will get this number. So if you add them, what is the meaning of the addition is uyx minus uxy, which is vxx plus vyy. This is my 0 because f is entire function, so u and v are my harmonic function. The first case is harmonic, this is satisfied. This is also harmonic, satisfied. Since this is 0, so this property also satisfied. Look at this one, vxy plus vyx. You can see if I add them, what will happen? No, if I subtract them, what will happen if you add them or subtract them? What can you say about this problem? If you add, I need a plus, so I can subtract them. So it will be uxx minus uyy, which is my non-zero. So this option is cancelled. A, B, C are the right answer of this problem. Okay, look at this one. U is a function which is a polynomial. For what value of the v, so that is my holomorphic function. So your target is to find u plus v is my entire function. Fine. That means your target is to find the v. The first thing is v must satisfy my harmonic function. Fine. So we can check about which one is not satisfied harmonic function. What is a vx minus 6xy, vxx minus 6y, vy 3y square minus 3x square, vyy is 6y, satisfied. So this one may be satisfied. Look at the second one, v of x 6xy, vxx 6y, v of y 3x square minus 3y square, v of yy is minus 6y, it also satisfied. Look at the third property, vx is 3x square minus 3y square plus 2, vxx 6x. What is the vy? Minus 6xy, vyy minus 6x, all satisfied, 0 all satisfied. So this result is not by harmonic, you can't discard them. Another is if it is the entire function, it satisfied my this property, u of y will be my minus of vx. So what is my ux? It is my 3x square minus 3y square plus 2, and u of y will be my minus 6xy. So firstly look at that. U of x is my this number. What is the v of y? For this case 0, they are not satisfied. What is the v of y? if you differentiate this with respect to y, it is minus 6xy, but we need this number. This option is also cancelled. If you differentiate this with respect to y, it's a 3x square minus 3y square plus 2 satisfied. What is the v of x? 6xy and minus 6xy satisfied. Yes, this is the right answer. Look at the first option. What is the v of y? 3y square minus 3x square plus 2, but we need a, you can see it's a minus 3x square, but we need a plus 3x square. First option is cancelled. Right option is B is my correct answer of this problem. Consider a polynomial of this number where capital D is the open circle or is the open ball, unit ball. Fine. Then P of, okay, firstly I can take capital N to be 1 because answer is not dependent on the capital N. What is my P of Z? N is my 1, so this is my A1 of Z, where A1 is my real number but apart from the 0. Then which are the following function? Now you can see this is my non-constant function. Fine. Also, if I call this is my f of Z, clearly say this part will be 0, so that means this is my entire also. Then your targets to be open or closed. Everyone knows that if f is a mapping from say C to C and f is my non-constant plus entire function, then f map open set to be open. Now you can see D is my open. Fine. Instead of the f, it is my P. Then P of D is my open. So P of D is my open. So that's a closed, cancel. Fine. Now, is it a bounded or is a subset of the R? It's a wrong because it's a it's a complex number because Z is my complex number. How you can prove that it's a bounded or not? Now, again is very simple because P of Z is a polynomial. Every polynomial is my continuous function. Fine. If it's a continuous function, it's an entire function. That means f of Z is my bounded function. Every bounded function of this. So right answers are my B and D are my right answer of this problem. I hope you can like and comment on this video. I will upload the next video based on your good responses in terms of likes and comments. F is my entire function, so that means CR equation satisfied. U and V satisfied my harmonic functions. If the Jacobian matrix is my symmetric, think about any of the harmonic functions. Very simple is I can take Z. Fine. Make sure this is symmetric of, or you can think about any of the symmetric matrix. Identity matrix is my symmetric matrix. Fine. Or you can take what is the U is X, V is my Y. Then what is the U of X? 1, V of Y 1, rest all are my 0. Fine. But now what the option suggested you? F is a polynomial. It may polynomial of degree less than 1. F is necessarily a constant function, but it is not a constant function. F is a polynomial of degree strictly greater than 1, but it's not satisfied. Now look at the first and the second case. F is said to be the entire function and this function is my symmetric. What does it mean? That means V of X must be equal to U of Y, but this is my entire function. That means V of X is my minus U of Y. So from equation number 1 and equation number 2, what you conclude? V of X will be 0. Fine. U of Y will be 0. If V of X will be 0, what does it mean? V is a function of, V is my either constant or function of the y on. Fine. Now f is a polynomial. Okay, so we can define what is the f dash. So u dash plus iota vx. Vx is my 0. So that means, because this part is my 0, so f dash is the function of the ux on. So what does it mean? If you integrate them, u is a function of this, so it means this is my, just like say this part, fine, or you can say it is in terms of z. Clear? So that means a function is my polynomial of degree less than or equal to 1. So is a polynomial of degree less than or equal to 1? Is the polynomial? Yes, this is also the correct. Also you can see from here, u of y is 0, that means u is either the constant or function of the x only. So u is a function of the x only, that means a of z plus b or u of this one. So the right answers are A and B are the correct answers. F is a holomorphic function, that means CR equation satisfied. U is the real part, V is the imaginary part. Then your target is to find this number. That means your target is to find derivative. Now we all know what is the derivative of the analytic function, ux plus iota vx. Now can you find the modulus of this? It will be ux square plus vx square, ux square plus vx square. What about the other one? Because this is the analytic function, so u of x is my v of y, u of y is my minus vx. So first one is the both are the u. I can substitute the vx. Vx is minus of uy, but of the square it also satisfies. V of y and u of y, I need to convert all in the terms of y. Ux is vy, v of x is u of y. Yes, this also satisfied. V of x, v of y. So this is the v of y. U of y is minus of vx. So minus square is plus square. So all are my correct option of this problem. I hope you can like and comment on this video. Let n be the positive integer. Take n is my 1. For the real number r is greater than 1, I can choose r is my 2. Fine. Then z will be my 2 e raised to power iota theta. Then the set, this consists of all this. So I can substitute this value. N is my 1, z is my this number, 2 e raised to power plus 1. N is my 1, z is my 2 e raised to power minus 1. So now this number will be, or I can write in the real and imaginary parts firstly. It's a 2 cos theta plus 1 plus iota 2 sine of theta. What is the modulus of this? It will be my 2 minus 1. So this number will be, it's a 2 into 2, 4. Fine. Okay, so it's a real component, it's imaginary component. So this number will be square root of 2 cos theta plus 1 plus 4 sine square theta, which is equal to 1. Now look at the option. Because n I have taken 1, it's my cos theta is 1. So if cos theta is 1, it's a 9. But if cos theta is 1, then what is the sine theta? Sine theta is 0. Are they equal? No. So first option is cancelled. Sine theta is equal to 1. Then cos theta will be my 0. So if cos is 0, then this number will be 1 plus sine theta is 1. So it's a 4, which is not equal to 1. Look at the third option. Cos theta is equal to minus 1. Cos theta is minus 1. It's a minus of 2 plus 1. It's a minus 1 square. If cos theta is minus 1, sine theta will be 0. So this is my 0. This is 1, satisfied. Sine theta is equal to minus 1. Sine theta is minus 1. Cos is 0. So this is 0 plus 1, 1. This is my 4, which is not equal to 1. So the right answer is C is my correct answer. Always choose the particular value of the unknown parameter. F is my meromorphic function, that is my entire function on the open set containing the unit circle C. F has no 0 and no pole. Let NP and N0 is the number of the poles, number of the zeros. And P is the number of the poles, and 0 is the number of the zeros inside the point C. Then which of the following statement is my correct? You remember what thing come in your mind when something is f dash over f? That is the argument principle. Number of the zeros. It's a number of the zeros minus number of the poles. Fine. But remember, it's a number of the zeros of the f. But if you look about that, it's a h of, I can take h is this number. Fine. Then in each case, your target is to find this part. Fine. So that means again it's a n minus p. But the difference is this, the n is the number of the pole of the h and p is the number of the pole of the h. Now, what is the number of the poles of the f and p? Now since it's a multiply by z, so number of the pole, what is the number of the poles of the h? It is same. Fine, because number of the it's a multiply by, and what is the number of the zeros of the, because it's a multiply by z, so initially it has a h and not plus one more 0 because of z multiply. So what is the right answer of this? I can substitute this value. This number will be my n0 plus 1, p is my minus 1. So your final answer will be n0 plus 1 minus np. So this third, fourth option cancel. It's a plus 1, but it's a minus 1. Only right option is A is my correct answer of this problem. Make sure, student, if instead of the h it is written like this way, then number of the zeros are same. Fine, but number of the poles is my increase by 1 because of this denominator. For the complex value function, d of f denotes the set of all those f, collection of all those f, such that f satisfied my CSIR equation. Then identify which of the following function is df is equal to c. What does it mean? Your target is to prove that function f is my entire function. This is your target. Fine. Look at this last property. Check whether the CR equation is satisfied or not. U of y 0, v of x 0, v of y 2y. Clearly say they are not satisfied. Fine. By the CR equation, you need ux is equal to vy. They are not satisfied until x is not equal to y. So that means this is my not entire. Similarly, if I look about this function, what is my u of x? This is my u. Fine. What is the u of x is? Alpha sine this number. What is the v of y? This is v. If we differentiate this with respect to y, minus alpha sine alpha y. Clearly say they are not equal until x is not equal to y. So that means this function is also not analytic. Fine, because they are not satisfy the CR equation. It means they are not entire. Now look at this first part and the third part. So let's firstly think about the third part. This is z raised to power 4. Now if I call this is f, what is this derivative? 0, because it is independent of the z bar. What does it mean? F is my analytic function. So once f is analytic function, the domain is my C is the correct option. Now look at this third option, first option. How you can check about the first one is, because f is z plus, here remember this mode of z is my this complex number, so you can't directly say this part will be my 0, you can't say that. Fine. So how you can do the first way is either you can change into the Cartesian coordinates. Fine, this is x square plus y square, and then satisfy the CR equations. Otherwise I can change into the polar coordinates. Iota, this is 1 plus r. Fine. Then what is my u? U is my real component. The real component is r of cos theta, and v is r 1 plus r sin theta. Fine. Now we will see whether the CR equation is satisfied or not. That means u of r is 1 over r v of theta. So firstly, what is the u of r? Can you find the derivative? I can write this is 1 minus 1 over 1 plus r of cos theta. Fine. Then what is the u of r? 1 will be the 0. It is my 1 over 1 plus r square cos theta. What is the v? Again I can return this part is fine. Then what is the v of theta? It is cos theta into this part, that's the r over 1 plus r. Clearly say, is it true? 1 over r of this part, they are not satisfied, because 1 over r 1 cancel, but it's a whole square, but it is not square. So it means this equation not satisfied the CR equation. That means it is not entire function. The right answer is only C is the correct answer. Let U is the bounded open set of the C containing 0. F is my holomorphic function. F of 0 is my 0. F of n is the composition of the n times. So let's say n is my 2. Then what is the f of 2 is f circle f. Fine. Then which of the following statement are my true? So first of all, f is the mapping from the u to u, where u is my bounded open set. That means by the open mapping theorem, this must be sets. Fine. But I need a f of 2. So firstly we will check about this property. What is the f of 2 of u? F of 2 is my f circle f. Fine. I can write this is f of u. F of u is the part of this. Again f of u is the part of this. So that means this option is the correct option. Look at the first one. What is the f circle derivative? F circle derivative. So remember how you can derivative the composition part, like g circle f. That means g of this part. If I call this is my h, how you can find the derivative of this? So that means g dash of fx into f dash of x. Fine. So now similarly, how you can find the derivative of this? I can return this is f of z. It will be f dash this into f dash of z. Now your target is to find the derivative values at the point 0. So the left hand side will be f square derivative 0. What is this number? F of 0. What is the f of 0 is 0. F dash 0 into f dash 0, that is f dash 0 square. This property also satisfied. Now look at the third and fourth option, f dash 0. Now look at the fourth option firstly. Which things come in your mind when f of 0 is 0 given to you and its derivative modulus? By using the Schwarz lemma. Fine. What is the Schwarz lemma is? F dash of z square. Now f dash of z, it will be less than equal to 1 minus fz over 1 minus z square. Now your target is to find the values at the 0. What is the f dash of 0? 1 minus f0. f0 is my 0 over 1 minus 0. That is a less than equal to 1. Also sets. Now, the sequence f dash 0 square is bounded. Definitely, because you can see this number is my less than equal to 1. If you remember that if r is my less than equal to 1, then whatever the power you can consider about that. This is also less than equal to 1. So I can take this is square, it's less than 1. It's a GP series. So yes, it is my bound. So yes, this is also the correct. For the positive integer n, f of n denotes the nth derivative. Suppose f is my any entire function, f is my 0. What is the f2 is? Nth derivative. So basically, this part is my f double. Fine. Now, can you find the solution of this? The solution is either sine of z or cos of z. Fine. And both are my entire function. Now look at that. Which of the following statement is my correct? And is there any derivative? So look at that. Firstly, I can check about this one. If I take sine z, for example, fine. What is the first derivative is? Cos z. Second derivative is minus sine z. Third derivative is cos z, and so on. At the point z 0, what is the value of this? Cos 0 is 1. Sine 0 is 0. Cos 0 is 1. Sine 0 is 0. Does it converge to the 1? No. This option is cancelled because limit is not unique. Does it converge to the minus 1? No. This option is also cancelled. F of n 0 is my convergent. Nth derivative. N is my 2. If I take n is my say 2. Fine. So the second derivative, this is my fine. But if I taken as a, what is the second derivative of this? Minus sine. And it is my minus cos. It is my minus 1. So, but you can see that the function is either convergent to the 0. If I take this function is my convergent to 0. This is my convergent to the 1 or minus 1. But it is, limit is not unique. It is not convergent. It has a convergent subsequence. Yes, you can consider, if I call this is my A, you can consider as a even series and odd series. Like you can see, first derivative convergent to the 1, second derivative, third derivative convergent to the 1, and so on. So odd derivative convergent to the 1. This is a convergent. Even derivative convergent to the 0. Fine. So that means yes, it has a convergent subsequence. F and g are my two entire function. G is my non-zero. G is my non-zero. F can be 0. Fine. Then f of z is the absolute value of this is my. Then we conclude f is my non-zero. Can you think about that? I can think about reverse. If I take f is my 0, can you think about any of the g which is my non-zero and entire function so that this property satisfied? Every constant function is the entire function. So clearly say this is satisfied, but the first function set is a non-zero, cancel. F is my constant function. Can you think about any of the non-constant function? I can choose e raised to power z. Fine, it's a non-constant. Entire function is the constant. I can choose non-constant. Can you think about any of the g such that this, okay, I can choose this is 1 over 3 and this is my e raised to power z. Clearly say this again property is satisfied. So f, but f is not a constant. This is cancelled. F of 0 is my 0. Can you think about any of the function whose value is my non-zero? If I choose f is my 1, fine. Can you choose about any of the g? I can choose g is my 2. Again, this is satisfied. Both are my entire function. But f of 0 is 0, not satisfied. So that means this is the right answer of this problem. How? That's again a very simple. You can see f and g are my entire function. Fine. That means f over g is also entire function. Clear? But from this case, I can say f of z over g of z is less than equal to 1. That means if f over g is my entire function, mod of f over g is also entire function. What does it mean? That means f over g is my bounded function. Now it is an entire function, it is bounded also. Any function which is entire and bounded, that means this function is my constant function. Fine. So if this function is my constant, so I call this is my c. That means f is equal to c of g is my right. F is a non-constant holomorphic function, that means entire function on the unit disk D. Always remember student, whenever the question is non-constant entire function, always first choice is my e raised to power z. After that you can think about the z. Okay, f is my this, f of 0 is my 1, satisfied. You may think about this function also. Fine, which is also the non-constant, and f of 0 satisfied. Then f is my bounded, f is my at most finite, infinite, f is my rational number. Okay, can you say about it's a bounded function? Clearly say f is my not bounded. Fine, because what is the mod of this? It is e raised to power x, e raised to power iota y. Iota y is my 1, but it is a e raised to power x, which is unbounded. So that means f is bounded, cancel. F is a rational number, that's again a cancel. Apart from this, you can also take any of the other examples. Like same example, you can take an as sine and cosine. These are also non-constant entire function. If I choose f of z is say my cos z, clearly say these are my not rational numbers. So this option is also cancelled, because cos of 0 is my 1 satisfied. There are infinitely many points in the unit disk such that f of z is 1. There are at most finitely many points which satisfied f of z is 1. Fine. Now, because I need to compute the modulus of this, so the best way I can choose this part. Fine. That means mod of 1 plus z is my 1, or I can say 1 plus x plus iota y is my 1. That means 1 plus x square plus y square is my 1. That means 1 plus x square plus y square is my 1. That means this is my circle. Center is minus 1, 0. Center is x is minus 1. Radius is my 1. So this is my circle. Now since they are equality, so that means we consider only those points which lies on the boundary points. Fine, which lies on the boundary points. So how many points which satisfied on this case? There are in like if I define the set X, collection of all those points of the Z, these are the points of the Z, such that f of Z is my 1. How many points on this circle which satisfied this condition? There are infinitely many points. There are infinitely many points on the circle which satisfy this condition. So that means their at most finite is cancelled out. Infinitely many is my right answer of this problem. You may consider as a e of z also, but then you have to write expand mod of e of z is 1 accordingly. Let f is the non-constant entire function. Always think about either e raised to power z or 1 plus z or z or sin z, cos z, and so on. Which of the following is possible for each of the z is belongs to this. Okay, again if I look about the first case, f of z is e raised to power z. What is the real part of this? I can write is e raised to power x, e raised to power iota y. What is the real part of this? E raised to power x cos y. What is the imaginary part of f is? E raised to power x sin y. Clearly say they are my not a. F of z is my less than 1. What does it mean? B part. F of z is less than 1. What does it mean? That means f is, so your target is to prove that function is bounded. Fine. Now clearly say again by this case, this option is discard. F of z, fine. Moreover, if assume that if this condition hold, if f is bounded, f is my entire, what does it implies? The function is my constant, but it is given that non-constant. So, and we already in the starting tips I already told you the non-constant entire function must be unbounded. Fine. So this is the bounded, this option is also cancelled. Imaginary part of f is less than 0. Imaginary part of f means v. V is less than 0. What does it mean? That means it's a bounded. If v is bounded, that means f is bounded. If f is bounded, that means f is entire also. It implies constant as well. But we need a non-constant. So this option is also cancelled. Only right option is D is my correct answer. Okay. F is my entire function. It is not given that it's a constant or a non-constant. F is my entire. Fine. Real part of the f, that is a u. U is my bounded. So what is the shortcut text for u? If u is bounded, that means f is bounded plus entire. If f is bounded plus entire, that means f is my constant. So that means f of z is my some constant function. F dash is non-zero constant. F dash is always 0. F is equal to 0. That's strong because f is a constant. It can be 7. F is a constant. Imaginary part of f is a constant. Yes, because if f is a constant, what is the imaginary component? Is also the constant. So A and B are the right answer. F is my entire function again. Imaginary part of the v f, that is v is my greater than equal to 0. What does it mean? That's a bounded. Fine. If v is my bounded, that means f is my bounded. F is also be given as the entire. If f is bounded and entire, again you can say f is my constant. If f is my constant, that means the real component is also my constant. That's 2. F is 0 is not necessary because the constant may be 7 or it may be -3 and so on. F dash is a non-zero constant, but if f is constant, what is the f dash? 0, but he said non-zero. So the right answers are A and B are my correct option of this problem. D is the unit open disk center at O in the C. This is the unit open disk, is the open disk. F is a mapping from the D to C. It's a complete C where F is my U plus iota V. Okay, F is my analytic function. So this is given to you as entire function. CR equation satisfied, U and V satisfied my harmonic function. F of Z is my power series. F is constant if F is constant. So your target is to prove this one. Okay, very simple. As I told you in my previous videos also, if F and F dash is my entire, what does it mean? F is constant. Fine. If F and F bar is entire, then it is constant. F is entire already given to you. If it means if this condition hold, F bar is entire, F is already entire. This means F is constant. Set. Fine. Look at the second part. u of half is greater than equal to u of z. What thing come in your mind whenever you are in the complex analysis and inequality is given to you in terms of the u or v? That means maximum or minimum modulo principle. Fine. What is the role of the maximum and minimum modulo principle? If I say u of a is greater than equal to u of z for all z, fine, and if you prove that this a is a part of my domain, fine, then you can say u is my constant. Fine. If you prove that by the maximum modulo principle, if you prove that this, or you can say this, the maximum attained at the point a. Now you can see my target only proof a is my half. Does it part of the domain? Domain is my this. It's a unit opposite, so half is lies inside. Yes, it's a part of this. That means by the maximum modulo principle, because it's a greater than sign, by the maximum modulo principle, this u is my bound or constant. So if this is my constant, so vf is also my constant. Okay, let me clear the screen now. Okay, look at this third option. The set n belongs to the an is 0. What is the an is? This part. Can you correlate this an with the function fn? The nth derivative at the point divided by n factorial. Fine. Now, an is 0. The set is infinite. Firstly, I can choose any of the functions, say sine of z. What is the first derivative? Cos z. Second derivative, minus sine z. Third derivative, minus cos z, and so on. I can choose any of the inside point. Let's say z0 is my 0. Then what is my a1? Fine, n is my natural number. a1, first derivative. What is the cos 0 is? 1. a2, second derivative 0. a3, third derivative, minus 1 over 3 factorial. a4, the next derivative will be my plus sine of z, that's a 0. So that means even part will be my 0. The set n, what is the set is? 2, 4, 6 and so on. Does it infinite? Yes, this is infinite set of the even numbers. Fine, so this property is satisfied. But my function, is it a constant? It is not constant, so this property is cancelled. For any closed curve this, okay, that's very simple. If I multiply by 2 pi iota on the both side, what is this given to you? Z minus a whole square. This means is the first derivative at the point a. If the first derivative is my 0, what does it mean? What is the f? F is my constant. Fine. So f is my constant is the correct option. So right answers are A, B and D are my right. You can solve this problem by the residue theorem as well. Fine. Or the complex integration as well. That I already explained you in my previous lecture. The same question you can also see in my power series PY question top. I hope you can like and comment on my this video. Let p is my positive integer. I can choose any positive integer, say p is equal to 1. Fine. Consider the closed curve of this, that means it's a unit circle. F is a function, is a holomorphic function. F has 0 at z0 only. Fine. And multiplicity is q. Okay, that's very simple. 2 pi iota f dash over f. You remember what is this condition? This is always my number of the pole, number of the zeros minus number of the pole. But you can see here the term some another function is given to you. So I will tell you the firstly general way. I can write this is my g. Fine, all are the function of the z. Then what will happen? Instead of the n minus p, it is my n into g of zeros, or I call as a n of n zeros minus pole into g of number of the poles. If it has more than one pole, I can take it as a summation. I is equal to 1 to number of the poles or the zeros, where n0 is my number of the poles, number of the zeros, np is my number of the poles. Fine. This p is my multiplicity of the pole, and this n is my multiplicity of 0. Now, fine. Now look at that. What is given to you? F is my entire function. If f is entire function, then what is the number of the pole? Number of the poles are by 0. That means multiplicity of the pole is also 0, and p is also 0. Fine. And what is the number of the zeros? What is the multiplicity of the 0? It has only 0. So multiplicity is my q, and n of 0 is my get 0. Fine. So this summation is my only for the 1. So what is the right answer of this problem? N is my q. G, if you compare them, G is my z of p, and z is my z naught of p, minus number of the poles are by 0. So the right answer is this one. So q into z0 raised to power p, but it's z0 q power p, but it's cancelled. Right answer is A is my correct. This is the most generalized format. That's a generalized argument principle. Okay, f is my entire function which satisfied f of z is less than equal to e raised to power y, where z is my complex number, and you can see it's a recent year paper. Which of the following statement is my correct? Very simple. I can choose the first option. Substitute this value minus iota times z. Z is my this value. I can open this e raised to power minus iota x minus into e raised to power y. What is the modulus of e raised to power iota x? Is a 1. So this is c e raised to power y. This is mod of c into mod of y. Now clearly say when mod of c is less than equal to 1 into e raised to power y. So which satisfied this property? Yes, first is the correct answer. Look at the second point. I can substitute f is iota x minus iota plus y is a minus of y. If I open this bracket, it's a c e raised to power minus y, which is c e raised to power minus y, but we need a plus y. It's a minus y. This option is cancelled. Look at the third option. It is e raised to power minus c iota x plus iota y. I can again open this one, c iota x e raised to power c of y. This number is again 1. It is e raised to power c y, but we need a y, but it's a cy. So this option is also cancelled. Look at the last one, e raised to power c iota x plus y. I can open this e raised to power iota cx minus cy. This part iota will be 1, e raised to power minus cy, but we need a plus of y. This option is also cancelled. A is my right answer of this problem. F is my entire function. Consider f of for some positive integer n. Okay, for some positive integer n, I can choose any of the value. Fine. If I choose n is 2, then this condition becomes second derivative will be 0. Once it's a second derivative 0, f will be my az plus b. Fine. F, if a is my c, then f is a polynomial, then f is my constant function. So constant will be cancelled out, it's a polynomial. If a is uncountable, then it's a polynomial, or a is uncountable, then f is a constant function. Now, if A is uncountable, what does it mean? That means this function is 0 for uncountable points. Fine. So if second derivative will be 0, that means if I say A will be collection of all those z in the C such that second derivative is my 0. Fine. Now just think about this function like of this collection of all those g of z is my 0. What does it mean? That means z is the zeros of the function g. Same case for this, z is the zeros of the f double dash. Fine. So that means, what does it mean? That means by the, once we are talking about the zeros, we call it as the identity theorem. Once it's identity theorem, that means f, this function is my identically 0 for all those z in my C. Fine. So once the second derivative is 0, again you can see the function is my polynomial. So it's not a constant, it's a polynomial, is the right. Okay, are the two non-zero. That means P of z is my non-zero, Q of z is my non-zero, and they are polynomials. Then this is my analytic. Remember that? How you can check about the analytic? Firstly, CR equation satisfied, plus their derivatives are my continuous, or if you prove that this part is my 0, then the function is analytic. Then firstly, if and only P of z is my constant. Fine. Okay. If and only. Firstly, you can see P is my constant. Fine. What I can choose and what value you can choose so that this property is satisfied, because it's a if and only. What value of the Q you can choose so that this is not analytic? Can you think about that? That's a simple. I can choose z. Then what is my P into Q bar? That is z bar, which is my non-analytic. Why? Because you can see derivative of this z bar is my non-zero. So that means P can never be constant. Fine. Look at the second option. P into Q. Product is my constant. Product is my constant. So again you can see I need to check about the analytic function. So what value you can choose on that? I can reverse that. If I choose P is equal to z, Q is equal to 1. This function is analytic. Fine, because the product will be my z and the derivative will be my 0. So this is analytic, but the product is my not constant. Fine. Now look at the third and fourth option. Q is my constant. If Q is constant, the complement is also the constant. So if I take P, Q is my constant. If I take Q is my 1, what is the value of the P I can choose? The value of the P I can choose as a z. Then this part will be my z into 1 is my z, which is analytic. Fine. What about this one? Z bar into 1, which is my not analytic. Fine. So which is not analytic, because the partial derivative with respect to this is my non-zero. So that means this option is cancelled. Only right option is C is my right answer. Let f be the entire function. If it is entire function, that means CR equation satisfied. U and V are my holomorphic, are my harmonic function. F is my constant. So f is my entire. It is given to you. Your target is to prove f is my constant. Which things come in your mind? If I prove that f is bounded, then f is my constant. Fine. How you can prove f is my bounded? F is bounded, either you can prove u or v is my bounded. Fine. So you can see the first case. If U is my bounded, that means F is entire, this is satisfied. V is my bounded, satisfied. U plus V. If U is my bounded, V is my bounded, U plus V is also bounded. So that means this also satisfied. U square plus V square. Can you think about how you can define? This is a real function. So U and V, that means now if I consider this is my F mod of F, fine. U and V are the real and imaginary parts of the entire function. So that means this is my bounded. Clear? Because F is entire, U and V are harmonic. That means U is bounded, V is bounded, U square plus V square is bounded, mod of F is bounded. That means F is bounded. So if F mod of F is bounded, that means F is bounded. So if F is bounded, F is entire, that means F is constant as well. All are my correct answer of this problem. F is my entire function. Which of the following statement is my correct? F is my entire function. F is constant if the range of the F is constant if the range of the F contains the straight line. Okay. F is constant if F has uncountably many zeros. F is constant if F is bounded on this. F is constant if the real part of the F is, that's a correct statement. The real part of the F, that's a U is bounded. If U is bounded, F is my entire, so bounded plus entire is constant. So D option is my correct option. Now, look at this, another one. Real range of the F. Range of the F is contained in the straight line. Fine. So what does it mean? The range of the F is my bounded. Fine, because if any of this straight line, let's say this straight line, how many points they omit? They omit the points from the complex plane. So that means all those points are omitted. So once, as I told you, the non-constant entire function has omit at most one point. Otherwise, the function is a constant. So range is omit more than 1 points. So that means range is bounded. If range is bounded, that means the function is bounded. If the function is bounded, function is entire, that means the function is constant, is the correct option. F is the constant if F has uncountably many zero. Again, the same by the identity theorem. Again, Z is the collection of all those C's such that uncountably many zeros. Fine. So that means F is my constant. So yes, it's a correct state. F is constant if F is bounded on real component of the Z. F is constant on this real of the Z. That means real of the Z is less than 0. That means X is less than equal to 0. This is my entire function. Let's see this one. E raised to power X, E raised to power iota Y. That means E raised to power X. Whenever X is less than 0, this part, what is the exponential part of this? This one, whenever this will goes to the 0 as X approaches minus infinity. So yes, this is my bounded as well. Fine. So if it is a bounded, it's an entire, that means this function is my constant. F is my entire function such that F dash is less than equal to the F. Then which of the following statement is my correct? Collection of all those entire functions. I think that's a repetition of the previous part. I can write this part of this. What does it mean? F dash over F is my bound. Fine. Also, we know f is my entire. If f is entire, f dash is my entire. Fine. If f dash is entire, f is entire, the ratio of the two entire function is my entire. So what you conclude from these two cases, f dash over f is bounded, f dash over f is entire. That means f dash over f is my constant function. That means f dash is equal to some constant of f. Fine. Now, what does it mean? Then your target f is a finite, f is infinite, and so. That's again very simple. So now f dash over f is my constant. So if I integrate them, ln of f is my c of z plus some constant. Fine. So f will be, or I can take it as a ln of, because the options are in the terms of the beta. Fine. So it will be my beta times e of, is alpha. So I consider this is constant, is alpha. Alpha of z. Fine. Where beta is my complex number. What is the alpha? What is the nature of the alpha? Whether alpha is the c or alpha is this. I can substitute this value here. Fine. F is my this. So that means if I consider this is my alpha. Alpha times of the f is less than equal to the f. That means alpha of f is less than equal to 1. So this option is the correct. This option is the uncorrect. Now since beta belongs to the c and c has this, the value of the beta is my infinite set, collection of all this infinite set, f is my infinite, f is finite, is the wrong option. So b and d are my correct. Now it's December 2023. F is a real value differentiable function. F is a c to c, but it's a real value. That's an important thing. What is the meaning of the real value function? That means f is defined on the c to c, which is a real differentiable function. What does it mean? That means u and v are my differentiable function. That's the meaning of this real differentiable function. Then u and v are defined as a real part of the z. V is my imaginary part of the z. Gradient of u is defined, which the following statement is my necessary true. Think about any of the function which is whose u and v are differentiable. A simple case is I can assume, fine, u is my x, v is my x. Clear? Both are differentiable function. Then what is the gradient of, what is the u? U is my x, v is my x. Can you find the gradient of the u? U of x 1, u of y 0. Similarly, gradient of v, v of x, v of y. Del of u dot del v. What is the dot product of these two numbers? Which is my 1, which is non-zero at every point. So this option is cancelled. C1 and C2 are my complex numbers such that the level surface are orthogonal. What is the meaning of the orthogonal? Your target is to prove this part should be 0. Fine. So that's again the same example. You can see I have taken that real differentiable function. This part is cancelled. If f del dot this is 0, okay, first C part, f is entire function. F is entire function means f satisfy the CR equations. U and v are my harmonic function. So what is my del of u is, because f is entire function, you can choose any entire function. I can choose as a z. Fine. So z means that's a x plus iota y, but in general this part, and del of v is my vx vy. What is the dot product of this? Ux vx plus uy vy. Does it 0 always? I have to apply because f is the entire function. It satisfies with the CR equation. Ux is my v of y. V of x is minus of uy plus uy of vy. Clearly say this is my 0 for all the pairs of the point. Yes, this is my satisfied. Can the converse be true? Converse need not be true. Why? You can see when this product will be 0. It will be 0 if I assume that this part is 0 and this part is 0. Or I can assume this part is 0 or this part is 0. So I think I can easily assume that. Can you think about any of the non-constant, non-entire function? Any of the non-entire function? This is my non-entire. Fine. Now you can see u is my x, v is my minus y. Can you find the gradient of u? 1, 0. Gradient of v is 0, minus 1. You can see u of x, I have taken v of x is my 0, and so clearly say dot product will be 0, but this is my not entire function. So right answer is only C is my correct. F is my entire function, so that means derivative of this will be 0. Fine. And this satisfies the CR equation, and u and v are my this. Okay, you have to prove that. Very simple. You always think about one constant z, z bar, and e raised to power z and so on. Fine. So if I simply take one is the entire function. This is one, all are my entire function. Let's say z. If I choose f of z is my z, which is my entire function. What is the f of z bar? Is it entire function? It's a non-entire function or not entire function. So this option is cancelled. Second part, f of z bar. Again, f of z bar is this. Again, it is my not entire function. This option is also cancelled out. F of z bar. What is? It's a z bar. This is my z. This is my entire. But we can't correct the option. Look at the last option. This is my z bar. This is my z bar, which is 2 times z bar. Again, you can see it is my not entire function because derivative of this is my 2, which is non-zero. So the only left behind is my C is the correct answer. If some more options are left behind, then we can think about the another, because this option we can't take on that because it's not entire function. Then we can think about this function and we can proceed further. Let f is a non-constant entire function. E raised to power z, fine, sin z, or you can take it as a cos z, or you can take it as a 1 plus z, and so on. U and v are the real and imaginary part. Which of the following statement is false? First option, ux is okay. What is that? This is my CR equation. Fine. If f is my entire function, definitely CR equation satisfied. So first option is my true statement, but we need a false statement. U of y, which is equal to v of x. U of x is my minus v of y. This is not CR equation. Fine. So that means this statement is my false state. F dash of z. Fine. What is the f dash of z? The complex number. How you can find the derivative is ux plus iota vx. Then I can find the modulus of this, which is ux square plus iota vx square. Ux square plus, sorry, it's a modulus, it's a iota will be cancelled out. Ux square plus vx square. Yes, this is also my correct state. Uy square, by the CR equation, ux is equal to vy. Ux is my vy and vx is my minus uy. Clearly say this satisfied. So this is also the correct statement, but we need a false statement. So the right answer is D is my correct answer. F is the mapping from open disk to the, again this is the open disk to the, so that means this is my open disk of radius 1 to closed disk of half. This is half, this is my 1, and 0 is my int. So 0 maps to the 0. You can define the map from, I call this is my A, this is my B. So F is the mapping from A to B, such that F of 0 is my 0. Then F of Z is my, again whenever F of 0 is 0 given, it is my open, so which result will focus on that. That is my on the Schwarz lemma. Fine. So what is the Schwarz lemma suggested you? This will be less than of Z. Fine. And the nth derivative, but we do not need the derivative, so I can skip on the derivative part. The first option is correct option by the Schwarz lemma. Look at the second option. F of Z is less than equal to mod Z over 2. I can return this number is half of the mod Z. Whenever Z is strictly less than of the 1 from the domain, it is strictly less than of the half, and strictly less than of the half is lies in this B. That means F is a mapping from the A to B. Yes, this option is also correct option. F of Z is less than equal to half for all. So this is the point from the domain A. Less than equal to half is the complete B. Yes, this also the correct option. It is possible that F of half is my half. That means it is possible that F of Z is this. That means I can say F is my constant function. So clearly say this is wrong. Why? As I suggested you in the earlier tips, if you prove that you have the two different points which are same, where alpha is not equal to beta, that means if it admit the 2 points, then only you can say F is my constant. But it has only 1 point, so that means it is possible, it is not possible that F is my constant. E of Z is my 1. Which of the following statement is my true? Very simple. You can see this first part is my right hand side is my real number. So when it will be the real number? Only when e raised to power z will be my complex number, purely complex, or you can say the purely imaginary part. That means I need to check this part will be the iota times of this. Fine. That means e raised to power x plus iota 1. Fine. Or I can say it is e raised to power x, e raised to power iota 1. Fine. So therefore you can say this part e raised to power, when it will be my purely imaginary number, when it will be the imaginary part, when this number will be my iota, then only it becomes my iota times e raised to power x. The modulus of this will be my 1. So that means e raised to power iota y will be my iota. That means cos of y is my 0, sine of y will be 1. Fine. So which case will be here? N pi. Sine n pi will be 0, but we need a 1. Sine is a odd number, so sine of the odd is a 1. Cos of the odd will be my 0. Y of n pi is my cancel. No, x, there is no condition on the x. X can be any number, but we need a y. So y is a cancel because n is equal to n pi for some. X can be n plus 1 of pi by 2 also, but we need only for the y. So B is my correct answer of this problem. F is my entire function such that f square plus f dash square is my 1. F is my entire function. Very simple. Clearly say f is equal to sine of z satisfied this function. Fine. Because you can see sine square of z. What is the second derivative is? Minus of first derivative. So first derivative is cos. So cos square of z, which is 1, satisfied. And you can see, because sine of z is lies between -1 to +1. But he said value only -1 or +1. X and y has a limit point. What is the rule for the limit point is? That is the identity theorem. Fine. If I define the set S such that z is my complex number, f of z is my 0, fine, it has a limit point, then f is constant. Fine, that is the meaning of this. Now look at that. If x has a limit point, if you compare this definition by this definition, instead of the f, it is my f dash. What does it mean? That means f dash is my constant. So if f dash is my constant, what is my f? If f dash is my constant, if you integrate them, f is also my constant. So third option is my correct option. Now look at the second option. Y has a limit point. If y has a limit point, again you can compare. What does it mean? F double dash plus f is my constant. Fine. Then f dash is my constant. Can you think any of the f? Clearly say, is this satisfied? Yes. F is equal to sine z, satisfied. But what is the f dash of this? F dash is cos z, which is not constant, but he said constant. So this point is cancelled. Now clearly say this and this, either one of them, either x or y has the limit point. But how you can prove that is actually the limit point? That means we need to prove whether this is 0 or this 0. That's again very simple. Is my 1. Since we need the second derivative, I can differentiate this. So 2f f dash plus 2f dash f double dash is my 0. 2 is common, f dash is common. F plus f double dash is 0. That means either f dash is 0 or f double dash plus f is 0. So clearly say this is my x, this is my y. Fine. So either x or y is my limit point of this problem. F is a function. Which of the following statement are my correct? F is z square 1 minus cos of z. F has a 0, 0 this. I will tell you the two different methods for this. First one is based on the numerical analysis. What does the meaning of the zeros of order 2? That means f of 0 at 0 is 0. F dash of 0 is 0. F double dash of 0 is my non. So you can take, firstly check f of 0 is 0. Yes. What is the f dash of 0? It's a 2z 1 minus cos z plus sin z into z square. So clearly say f dash of 0 is my 0. Satisfied. And you can check whether f double dash is 0 or not. Similarly, for this case is of order 1. That means add the 2 and pi. This number will be 0 and this will be my not. Fine. Similarly, it's a 4 order. That means that up to the triple derivative is a 0, fourth derivative is not. But that will take a very lengthy calculation. Second method is, you can see about this function. They are talking about the 0, 0, 0, 0. This function z square. What is the zeros? Is 0. What is the order is 2. Fine. Can you find the zeros of the 1 minus cos z? That means cos z will be 0. So cos z will be 1. So what is the value of the z over the complex plane? Either 0, either the pi by 2. Cos 0 is a 0. Then next value will be at what value of the z? So that cos z will be 0. Is 3 pi? No, it's a 4, it's a 4 and so on. Fine. Now, you can see how many orders you have. How many orders you have? How you can check about the orders? 1 minus cos z. If I consider this is my g. Fine. Now, what is the g of 0? Cos 0 is 1, 0. What is the derivative? Sine of z. What is the g dash of 0? 0. What is the second derivative? Cos of z. G double dash 0 is my non-zero. That means this, how many zeros you have? How many zeros order is 2 order. This function is also as a 2 order. So how many zeros of order? 0 has order 4. So this is the order 2, cancel. Third option is correct. Now look at this f of order 1 of 2n pi, 2n pi and 2n pi. Now this function has any order of 2n pi? Zeros of order? No. So I will check about this one. What is that 2n pi? Cos of 2n pi 1. What is the g dash of 2n pi? Because n is my integer. Sine of 2n pi is 0. What is the g dash of 2n pi? Is my plus 1, which is non-zero. That means this has the order 2. G and g dash has the order 2. Fine. This is wrong option. C and D are my correct answer of this problem. Okay. F is defined as z bar square over z. Which of the following statement is my continuous everywhere? What is the z bar square? X minus over x plus iota y. If I open them, it's a x square minus y square minus 2xy iota over x plus iota y. Fine. Now clearly say the degree of numerator is greater than the degree of the denominator. So this limit will goes to the 0 as xy will goes to the 0, 0. That means the function is my continuous at z which is not 0. But also given that z of f of 0 is 0. So that means function is continuous for all z. Fine. So function is continuous for all f. Otherwise, if you don't remember this shortcut tricks, you must watch about the function of the several variable PYQ lecture. I already explained. Otherwise, you can also solve this function as by taking the path. Fine. By taking the path y is equal to mx, and you can see prove that this is a continuous function. F is not analytic in any open neighborhood of. So that's answer because the function is continuous everywhere, differentiable everywhere. Degree of numerator is greater than of this, so it's an analytic function. He said not analytic. F of z is analytic in the sum open interval. Yes, f of z is analytic function. Now z into fz. Z into fz is z bar square. That means is satisfied. Okay, so I called this is my g function. Then how you can prove this satisfy the CR equation? I can take that derivative. So clearly say what is this property? This is 0 only if so at 0. So you can see at 0 at z is equal to 0. What is the z bar? 0. So this value will be 0. Function whose derivative with respect to z bar is 0. That means g is satisfied by CR equation. Yes, this satisfied CR equation. So A, C, D are my correct answer of this problem. Consider the function f and g which are defined like this manner. F is e raised to power z. G is e raised to power iota times z. S is the collection of all those z. Real part of the z. That means x belongs to the minus pi to plus pi. F is on to G is bounded, F is bounded, G is bounded. Firstly, we can check about the bounded. E raised to power x, e raised to power iota y. So that is e raised to power x. Fine. Now since x is bounded, so e raised to power x is also bounded. That means mod of f is bounded. That means f is bounded on S, because this x is bounded only on this S. F is bounded on the S is the right answer. Fine. Now look about this. F is on 2. F is entire because e raised to power z is my entire function. Yes, fine. Does it on 2? No, because we can't find any of the z, so that this value will be 0. Fine. E raised to power z can never be 0. So this is not an onto function. G is bounded on the S or G is bounded on the C. Again, I can start from this e raised to power iota x minus iota y. So e raised to power minus 1. Now since on the S, there does not exist any restriction on the y. So that means, but e raised to power minus of y, e raised to power minus of y, is it bounded? No. E raised to power minus at y is not bounded because what is the y? Y is from minus infinity to plus infinity. Fine. So that means this is not bounded on this S. G is not bounded. G is not bounded on the C as well because there is no restriction. So C is my only right answer of this problem. F is my non-constant entire function such that image of this. That's again the same tips as I told you. The non-constant entire function omits at most 1 point, or you can see the image of F is either C or C minus at most 1. The interior of the image F is empty. That's false. Image of the F intersect every line passing through the origin. Okay, there exists a disk in the complex plane which is disjoint from C. There exists a disk in the complex plane which is disjoint from the image of the C. That's wrong because because either the image is C or C minus. Image of F contain all the limit point. That's wrong because the limit point of C minus is A, but it does not belong to the image of the F. So image of the F intersect every line passing through the origin is the right answer of this problem. Okay, F is a function. Which of the following statement is my false? F is my non-constant entire function, and they are talking about the open, so we can use the open mapping theorem. Fine. What is the open mapping theorem? F map open set to be open provided F is my non-constant plus entire function. Now since F is already a non-constant entire function given, so which of the following statement is my false? So first one is F, is this open? Yes, this is open. So F open map to the open, but he said not open, so this is my false statement. This is my non-open, so F not open is a not open, that's a correct statement. This is my it's a closed, fine, it's a closed to the closed. It's unbounded, it's open, fine, but it's unbounded, Z mod is greater than 1, so yes, it's unbounded, so this option is cancelled. Only A is my right answer of this problem. I hope you can like and subscribe my YouTube channel. We will see the next lecture on the Taylor and the Lorentz series. Till then, you can share this video with your friends. Best of luck, students. Happy learning.